haciendo, brother? Thank you very much for coming, and thank you to the organizers for having me here. Uh, Today we are going to talk about escaping from Mars, but as I said, this is going to be just an example about how good engineering is done and how to use that in our everyday work. Uh, for those who don't know me, who would be probably all of you, I do training and I do consultancy for some companies, mostly related to advanced topics in iOS and Android. And this should be it. No, no, don't worry. That's fine. Is it? Yeah. So today, I wanted to talk a little bit about architecture, but instead of talking about design patterns that we commonly use for architecting, I instead prefer to talk about principles and starting with how a big company like NASA can be an inspiration to all of us in terms of how to do great engineering. So we will start talking a little bit about NASA. Now I'm still a little bit scared because of his knowledge about that, so if I make any mistake, I hope he forgives me. Also you, but I would like to give you some examples on how they do things and how this could be applied to the applications or the kind of job that we usually do. Then we will go on and we will talk a little bit about solid principles. And when we talk about that, I will explain how they apply to creating a nice architecture. And finally, I will briefly go through some patterns and how they can be applied. This will be Swift-specific examples and how they can help us also to have a great architecture. So this is what we are going to talk about today. And let's start with NASA. And well, I decided to use this example because I read the book, The Martian. Who has read The Martian or watched the movie? Great, okay. So I'm not afraid of giving any spoilers away because now like almost everybody has watched the movie. That's great. Still, don't worry if you haven't because I'm not trying to spoil the book or the movie. These are going to be examples that you can even still see, watch on the trailer or anything like that. So don't be scared about watching the end of the movie in my next video. Let's start from the beginning and let's talk about what NASA does in order to put somebody in Mars. So when they plan to do that, you know that NASA is famously known because they have to get the approval from the government in the States in order to get enough budget to have the missions. But when they do that, they have a big issue because the presidential mandate there is only 4 years and a president can stay no longer than 8. So their missions have to be somehow restricted to 8 years because otherwise the president who allows them to get the budget won't benefit from the publicity of a successful mission. So they have to break down into pieces whatever they want to do in order to have this mission accomplished on time during the presidential mandate. I guess that all of you are not thinking that in order to put a person in Mars, they start doing that from scratch with the initial goal of having a person or a team there. That's not suitable. I mean, that's something that cannot be done like that. Usually what they do is they first send a probe, then they start taking pictures from outside the atmosphere of Mars, then they do something else there in order to measure the speed of the wind there, the temperatures, how the ground is there, and all this stuff. And in order to do that, they will send a second probe there, and a third one, and finally, sometime in the future, they will send some people to Mars. So this sounds somehow related to what we hear when we listen about Agile and the minimum viable product. Our minimum viable product cannot be to put a person or a team in Mars in the first stage. When the product manager tells you that, that's something that you should say no and reject. So in this case, that's something that they have, that they take into account seriously. Second thing that they do that I think is something that we should learn from is they always grow from what they have. Instead of creating something and dismissing it after the first mission, they create something that they can rely on for not only one, but several missions, and that's something that helps them. They reuse their infrastructure as much as they can. Obviously, some of the parts of their missions cannot be reused, but as much as they can, they try to take advantage of what they have already created in order to empower next missions that they are going to try. It is even more important that if you put a team somewhere, especially in the moon, or Mars, or even farther away, that you try to avoid every single point of failure. Something that by breaking this stuff, anything will be screwed. You don't want that. You want something that if this is broken, then you at least have this alternative that you can rely on and that you can use in order to have something that makes your application, your mission still go on. So this is very important too. But if you have problems, and you will have them, you want to know where these problems are coming from. You want to know that the main reason, the root cause for the problem is in this part of your ship, or is this part of the suit, or anything, but you can detect where the problem is coming from and act based on that information. That is also key if you want to iterate fast and to be able to grow and deliver new features for your mission. It is also important that their missions are not meant for 1 year or 2 years. They are meant for many years. Some of their probes are still sending information to us, and they have long past their expected life. So now we are still getting information from some of the probes that were sent like 20 years ago, and the information is very valuable because it is coming to us with a long delay, but it is providing us with more information that we were expecting from those. In order to do that, they, as you can imagine, they are not dealing with the old technology that they had at the time that they sent the probe. They are still using those probes, they are still using those communications, but they are interfacing these communications with their new systems. And that is also important. I mean, you have to adapt. You sometimes are forced to use some old technology, but you want to take advantage of the new things that come to you. And you want to adapt to still embrace that technology that you are forced to use, but as long as you can, you would like to use technology that is newer. This is what they do too. It is very important, and it's probably a huge issue for many teams here, that they are able to work together. And that means not only that you can put 3 people in Mars and they start doing things. No, they can do it at the same time. I don't know whom I was telling that story to, but yesterday we were talking about the storyboard. Maybe it could be this morning, but we were talking about the storyboard. I was to Julius and sharing the deck. Yeah. So if you have a storyboard in your code, and who has a flag here or a DAC or something that is held by the person who is changing the storyboard, so nobody screws the storyboard, and when you get a commit, you get some conflicts in the new commit. That's something that happens in teams because like many teams avoid using storyboards because of that. So you want your teams to collaborate. You want your teams to avoid stepping into each other's toes. You want your teams to be efficient. That means working concurrently and providing its maximum throughput. And they do that. They design the missions so everybody is busy providing some new information and doing something that is valuable to the team. But the truth is that no matter how much they plan in advance, how well they do that, shit will happen. they will have problems, and they will have to be ready to do the maintenance, to do that in order to fix the problems that have appeared, and to react to these problems accordingly. That's something that they have to keep in mind, and they are monitoring the missions all the time. The book is a good example of something that could actually happen in terms of that. But the truth is that this has happened before. I mean, they have had missions when they were taking people to the moon. They have had problems like that, and they were able to react and save many lives because of that, and save missions that were otherwise doomed because of some small problem. So, let me ask you now, how do you feel about your architecture? Let me ask you, and this is going to be a very easy question, so I want to see hands up or hands down. Who feels very happy about your architecture? I mean, like really proud. Not much pride here. I mean, like, okay. Who feels that, well, they are doing okay, but they would like to do better? Most people. Okay. Who feels that they are doing below average? Some hands. Okay. That's cool. So I think that some of the things that we have to address are the kind of problems that I was mentioning when I was talking about NASA. I would like to be able to grow fast. I would like my application to be able to adapt and include new features that our product management is telling us to include, that the business requires us to include in the applications because they want to remain competitive, to be on top of anything. So I want my application to be able to adapt to all those changes. And in order to do that, I want to avoid that when a change is done here, it breaks everything else in the application, and I cannot find the real reason other than removing that commit and praying that removing the commit deletes the problem. I don't want that. I want to be able to grow as fast as possible. I also want to have an application that is robust, that has as many tests as I can include. I would like to have a big coverage. Let me ask you about that also. About testing, and we were talking about before the talk. So how many people do unit testing in their apps? Yeah, okay, very well. Congratulations. How many people are covering over 50%? Not so many, okay. Okay, cool. How many people do TDD? Some hands. It is funny because many of the hands that were in TDD were not the same as the ones that were above 50%. I don't understand that. Somebody can explain me this after the talk. But still, if you are trying to create an application that is reliable, you want to have as many tests as possible, and you want to be able to detect when some change that you have introduced in your code is breaking something else. And also, you want to have your code as much decoupled as possible, so changes in one part of the code don't affect to any other part of the code that you have. You also want to be able to debug properly your code, and that means that you know where your problems are coming from. You want to know that if it is a problem in the display of the information, that is probably related to the class that is responsible for presenting the information to the user. And that is something that you can address in a faster way because you know which one or two classes you should review in that problem. Also, you want to be able to collaborate, and that's something that is really required. I mean, I would, ideally, I would like to have a team that at the beginning of the spring agrees on how things are going to happen, and they can decide either to talk to each other or not, but after the 2 weeks of spring or however long you make it, you can put all that code together, and every test passes, and everything is working fine. That's not a dream. It can be done. I want my code to be reusable. I want it to take advantage of something that I've written for other projects or for other parts of my application. I want this to happen as much as possible because that's savings for the project. I could dedicate more time to other things that are more visible to my customer or to my manager. I also want to be able to defer the decisions as much as possible. If I start by saying that I'm going to use core data, AF networking, and I don't know what else, and reactive, probably I'm doing it wrong. Because that's something that may change in the future. And, well, I may have a request to use some other persistence framework, or I might have some reason to use another networking framework, or I don't know why. But you better defer those decisions as much as possible. So when you take the decision, you have as much information as possible to take the proper decision for that framework. Finally, I want to be independent of the frameworks. Because if I'm using the same frameworks all the time, that's fine. But if I have to change, imagine, for example, and this could never happen, okay? So close your eyes, think that this could happen, and imagine that you have written an application that is using a persistence framework on the network. Let's call it parse, okay? And now you are using this framework, and the owners of the framework decide not to use the framework anymore, not to support it. And in order to change your application so it uses something else like Firebase or whatever you feel like, how much do you have to change your application? Is just a small change, or is the code of parse all around your application? Are you screwed or completely screwed? So that's the difference. As long as you are independent from the frameworks, you can do changes and not being affected that much for these external factors that you cannot control. So, okay. There is a way to do that, and I'm not that smart, so I'm just going to tell you the things that I have learned from people smarter than me, but my recommendation would be to use solid principles and to have an architecture that respects those principles in order to be able to do all these things properly. And the name of this is also known as the clean architecture. Probably many of you have seen the talk, or one of the many talks of Uncle Bob about clean architecture. How many? Okay, great. How many have tried to apply these recommendations to iOS or Android code? Okay. How many have succeeded? Great. That's the point. So the thing is that probably you saw the talk, you listened to what Uncle Bob said, which I think he's a very smart person, and as Matt was pointing me out before, a very charismatic person. And you see that, well, his ideas are great. I would love to apply them. And I would love to know that this can be used in my architecture. But I would say that his ideas are more the principles that are behind the architecture than an actual design of the architecture itself. And that's what I'm going to try to explain now. So if you are somehow skeptic about this being possible because you have tried and you haven't succeeded, I'm telling you that it is possible and it can be done. There are some companies that are implementing this already. I have some examples in my GitHub account, and still, you probably know about the Viper implementations that some people have shared. I think that most of the implementations that I have seen so far are somehow restricted. They are not covering every case. I mean, like, they are just starting to showcase that this is possible. But it is completely possible, and it has some advantages that are not foreseen when you try to read an article about Viper or when you see something about Viper. Let me try to explain a little bit more about the architecture, even though some of you at least, know about it. I would like to review the concept so everybody's on the same page. So what we have in an architecture is usually we describe an architecture like the way the app behaves and how it interacts with the frameworks and the system. This is really poor. I mean, like, this by itself, that's no architecture. So instead, people think that by having different view controllers or activities if you are using Android, that's somehow an architecture. And I completely disagree with that. I mean, like, this is just the basic way of organizing code, but that doesn't help you anyhow because, as you would have noticed when you wrote your first application long time ago, I know that you are not doing that now, but you were putting some logic in your activities or view controllers. You were doing some display logic also in the view controllers. Your model is somehow referenced there. You use something like NS fetch results controller in your view controller. Who has done this? Nobody. No. Don't raise your hands. Okay, so nobody does that because they know it's wrong. But still, we are still talking about architectures like the ones that Apple or some others are trying to sell us as effective. So let me change a little bit the picture. So we have the system at the bottom. We have the frameworks, which are usually our interface with the system. And we have these view controllers. But they have told us to use model view controller. That's the reference in Apple's documentation. And I think that's a nice one. I mean, like at least that's better than putting everything in the view controller. You know the rules. I mean, like everything that is business logic should be in the model. Everything that is view related should be in the view. And everything that is glue should be in the controller. And where is the network? And where are the statistics? Where are the sensors, if I use them? Where are those? I mean, like, it is very easy for the very simple case that you have a table and you want to show it. Okay. I don't know about your applications, but I can guess that this is not your problem. Your problem is much bigger than that. Your problem includes some sensors. Your problem includes some information that is covered by this architecture. Okay, so you have started to do some research, and you have found that if you change the word controller by the word presenter, nothing is gained. I mean, like, yes, okay, I mean, a little bit better. The main difference is that I have a view here that if I do the model view presenter properly, it is passive. That's it. That helps me a lot in order to do the testing of the view, or at least to do the testing of everything else in my application. But still, some questions are still there. I mean, like, we haven't solved where to put the network. We haven't solved where to do the other stuff. And that's something that some people can tell you, oh, but we have model view model. Sorry, but I don't see I mean, I see the difference. It's a different paradigm, and it has some advantages, but it is not solving the whole picture that we are trying to address. So what do we do instead of that? Well, Uncle's proposal is to use clean architecture, and it is all based around entities. And entities are any structure, any data value type that you use to define the data that is addressed by your application. So if you have a to-do list, the application that everybody in this room has created already, a task would be one of those entities. If you have a shopping list, a product will be one of these entities. If you have a contacts book, so a contact would be an entity. And it would only contain small bits of logic that could be shared among applications. So these structures, these value types, are mostly dumb. They are immutable, and they can be reused as much as possible. Then you have something that he refers to as an interactor, and that interactor is something that contains the business logic. In some cases, the business logic seems to be very dumb. I don't agree with that idea. It is actually the piece of your code that offers you a catalog of the features that your application contains. And if you do this properly, you will have this catalog of features that your application can perform, and you can reuse them from every view controller that your application has. So if you have written the use case for mark as favorite or put a heart there, then you can reuse that feature everywhere else in your application. Great. The next thing on top of that would be the presenters and the entity gateways. The presenters are responsible for holding the presentation logic, for transforming the data that the interactor have provided to us and give it to the view. The entity gateway is the gateway, the bridge, for our application to contact to any data source. It could bring data from the network, it could bring the data from a local persistence framework, or from a plist, okay? Then, on the outside circle, you would have all those frameworks that we were using before. Because, in case you haven't noticed, UIKit is a dependency of your application. And we would like to isolate that dependency. And the reason for doing that is that we would like to be able to port our application from iOS to OS X as fast as possible. Not only that, we would like to use our use cases and reuse them in a Watch OS application or in an Apple TV One. So you are actually reusing your code as much as possible and enjoying the benefits of an architecture that helps you to grow. Not only those frameworks, but also the network ones that I was mentioning, or the location, or any other sensor that you can imagine, or any other framework that is a dependency of your application. So the rule here is that you will have the dependencies from the outside circle to the inside circle. That means that an entity will not know anything about a framework. It doesn't know what the UIKit is. It doesn't know what a view is. It doesn't know what a slider is. It doesn't care. Same thing for the persistence framework. It won't know what an NS-managed object is, and that's important. So the NS-managed objects are outside of the business logic. The business logic will know what an entity is, but that's about it. It won't know about the presenters. It won't know about the entity gateway. How do you build that in iOS? Well, I mean, like, same thing that we were mentioning, and the only rule here is that, well, there are different pictures for this, but the only rule is that you have to inject this when you have a segue. If you're using storyboards, they are welcome here, but you have to inject the presenter, the interactor, and the entity gateway when you are actually creating, through the segue, the view controller. Behind this entity gateway, you can have as many data sources as you want. So this could be a reference. And the interactor will hold the use case that this view controller has. And if you have created any actual application, you will be thinking, oh, but my view controller has several use cases. Well, you can have several interactors here. And it will implement the command design pattern, which will also help you to reuse and undo, okay? Very helpful there. And the only rule, as I was saying, is to create the ownership in that direction, and these are weak dependencies. So you don't have a memory leak when you release all the stuff, okay? So I don't want to go into the details because I told you that this is not the goal of this talk. I instead would like to talk about the principles that are behind this architecture. So the first one of the SOLID principles, you know that SOLID is an acronym, and the first one is the single responsibility principle. And as I was saying before, model view controller is not enough. It is not enough because what you have is, in terms of responsibilities, is more than 3. So you need to divide this into more than 3 pieces, because otherwise you're doing it wrong. A single responsibility principle states that a class should have only one reason to change. And that is I mean, everybody, when the first time I heard about the single responsibility principle, I thought, oh, that's pretty clear. I get it, and I know how it works. But it is not that easy, and then sometimes it's a trade-off. Sometimes you decide to include functionality, thank you. Functionality, but in an entity or an object, sometimes it is better to put it in a different class. Let me give you an example. So for the shopping list that I was mentioning before, having the characteristics of the product, like the name, the description, or whatever you're going to buy in a shopping list, that is something that should go into the product. But the number of items that you want to buy of that product is part of the same object, or is it a different entity? Probably a different one, okay? So responsibilities here are clear, and sometimes you want to divide it, sometimes it's more efficient to keep them together. But you have to adhere to this principle as much as possible. Notice that it doesn't say law, it says principle. Shy, okay? So let me give you an example of how this works. This is an application that I created for the trainings, and this is an application that has the talks for the NS Scholar Nights in Madrid that I organized. I created an application because I always forget when people tell me, I want to talk for your group, and it is a mess, so I decided to have an application and prioritize the talks and give them a slot in our next meetup. So the first interactor, the first use case that I included there was to be able to list all the talks that I have available. So what this does, as you can see, is to grab from an entity gateway all the speakers. It will have them here in the entities. Then it will convert the data into something that will be displayed, and it will send the data to the presenter. So this is mostly grabbing data, changing it a little bit, or filtering the data that it doesn't require, and sending it to the presenter. And well, if you have never done this before, you may think that that's dumb, because you are only losing time to process some information that you already had. And well, you can optimize later on if you need to. My perception is that you shouldn't optimize before you notice that there is a bottleneck there. But still, what is more relevant here is that this use case is a very simple one, just in order to illustrate the concept that I was trying to tell you. But it is not very uncommon that you have to combine information from two or more entities in order to create the information that has to be displayed to the user. So in the example of the shopping list that I was mentioning before, this information will be combined from the number of items and the description, and you will display that in the shopping list that you are going to present to the user. So the open-close principle, that is the one that has less friends. It's a poor principle, be friend of him. The thing is that most people don't understand this principle, and I'm going to try to give you an example from real life. What the principle states is that a class should be open to extension, but close to change. So whatever you have done, it should be not modified in order to adopt new functionality, but you should be able to adopt this new functionality. So if I'm not changing anything, how am I able to do that? We should learn from real life. We should go to restaurants, and I don't know here, maybe the example does not translate to this country, but in Spain and in many other places that I've been, if you go to a restaurant, there are those nice restaurants that have very nice menus that are printed as a whole book with all information and very nice prices. And there are these other restaurants that have plastic sheets that they have the printed paper inside, and they change those in order to show you whatever it is that they are offering that day. So if they have a different dish for that day, they will change the paper, but they don't create anything new. The menu is there. It is open for extension, so if they want to add cocktails, they will just put a new paper, but closed to change. The plastic sheets are there and they won't be changed. Same thing happens in your code. And even though you haven't realized, you are using this principle every day. If you are using a UI table view, the delegate pattern is using that principle. So the UI table view has been already created for you. It is close to change, but is open to extension. You can modify the behavior by modifying the delegate and the data source. Okay? Next one is the Liskov substitution principle. And this principle is better explained by telling you a violation than by actually doing what the principle states. So if you are using a class that is a rectangle and you write code in order to calculate the area or to do anything with the rectangle, it is very complicated to think about a square that does not change one or the other, so the height or the width, based on the change to the other. So you would have, I implement a square, and I would say, oh, I would call this side, and when you change the side, I would change both the height and the width. So if a class is using the rectangle and does not know about this rule, because that's not a true rule of a rectangle, everything that will use this class and gets a square instead of a rectangle, it will have problems, because it makes an assumption of the behavior of the main class, of the base class, that does not apply to the derived class. We do this almost every day. I mean, like when we implement every class in our application, we must fulfill some rules. I mean, like when we create a view controller, it should obey in a certain way to some expected behaviors. I mean, like if you override the viewDid load, you will have to behave properly. If you override the viewDid appear, you will have to call the parent subclass. So these rules are required for you to follow. Otherwise, you will be breaking what a derived class is supposed to do. And your code will show that sooner or later. The dependency inversion. And for those of you who already knew some of this stuff, but were not very familiar with the application of the principles, if you have to take one outcome of this talk, I would recommend you to focus on this one. This is the most useful stuff that comes from the 5 principles that we're going to talk about today. The 5 principles include this one that is about how to make your code independent from something else. So usually, if you're using core data or any other framework, you have mentions in your code that use a class that is part of the framework. Instead, what you would do is to agree upon an interface, agree upon a protocol, and then you talk to a class that implements that protocol, and instead of using directly the core data framework, you would use a class that implements all the interface that you have agreed upon. Then this interface will help you in case something like parse is removed or not supported anymore, and then you can, from that point on, change whatever you have there, and as long as what you put there fulfills with the interface that you have designed, you will be safe. That's something that is really useful, and this is something that in the clean architecture is used all around. You will have tons of protocols, but this is just an example. So here, I'm using an entity gateway, and notice that an entity gateway is anything that supports this entity gateway delete protocol. A protocol that I have defined that allows me to delete one entity. So that is the isolation that I get from the other class. So I could put a core data class behind that. I can put a realm class behind that. I can put a plist or an in-memory repository. It wouldn't matter. There would be no change. That's what is so awesome about this principle and what it makes it so useful. Notice that I have changed the order. So it's not that we say in Spain sol di, no. It's that I prefer to go with the D before the I because this one can be understood better if I had explained the other one first. So the last one that I had to explain is the interface segregation. And the interface segregation principle is the one that allows us to segregate the protocols so you don't force a class to implement every method when only one or two are required. So you have that segregation of the interface, and that will help you to have thinner classes that can be tested more easily and that are responsible for less stuff. What do we have here? I mean, this is an implementation of an in-memory repository, and notice that I have 3 different protocols. So I have one for the fetching the data, I have another one for creating a new entity, and I have a third one for deleting. Obviously, you have some more, at least another one for updating, but I want them to fit here just to be somehow readable. But I hope you still understand what I'm meaning. I mean, this is not restricted to 3 or 4. The main goal of this is to separate the interfaces so you don't have to implement, for example, when you are doing a mock, you would only need a mock that implements that method or these 2 methods, okay? So now that I have talked about these 5 principles, as you can see here, the principle is all around. I mean, we have different classes here, and we have a lot of them because every one of them is responsible for just one thing. And if we have to have a repository that is able to do both, like grabbing data from the network and grabbing persistence information, they would do that by having that covered by a repository interface. Same thing with the 2 ones that I mentioned, the open-close and the Liskov principle. They are all around because they are required, so otherwise the behavior would be unpredictable. But the dependency inversion and the interface segregation is required in order to make all these independent, in order to make all these layers independent and to be able to talk from one layer to the other. That's what really helped us here. So as you can see, even though the definition of the clean architecture was pretty clear when Uncle Bob was talking about that, it is the principles that are behind that what actually help us to create an architecture that is valuable to have all these benefits that I was mentioning before. So I will be fast. How long is it? Okay. I will be fast with the design patterns because we don't have much time. The design, just want to mention a couple of them. And my first one would be not about the guard, which is, when I'm talking about design patterns, I'm not talking about how good the new features of the language are. We already know that. I'm not talking about the ability to use error handling in Swift because we already know that. We know how to do the handling of the error, and that helps a lot to the new code that we are writing. But I'm actually referring to design patterns like the ones that you find in the Gang of 4 book. In this case, I'm mentioning the null object. Like probably you have read code like this that uses this kind of returns an optional, and it has to check every time whether the optional has a value or not in order to provide or print some information. I'm not saying this is wrong, not at all. But in some cases, you want the behavior by default that can be provided by using a design pattern. How do you do that? So you derive a class that is called the null object class. In this case, is a null sample. And it is a subclass of the other one, and it has default behavior. So if it has a null value, you will be able to return this class, an instance of this class, instead of a nil. And this default behavior will be provided here without any binding, any optional binding, or any change to the code. That is much more readable and much more easy to understand. Finally, we will have the template. For those coming from Java, you probably are missing the abstract classes or the abstract methods. And we don't have those in Swift, as you already know. So some people write code like this. Some people say, well, when I want to create a mission of an astronaut, then I would do these three steps. That is, get into spaceship, travel to destination, and come back. But since I'm going to change this mission every time, the travel to destination will provide a fatal error because I don't know what is going to be in the implementation. That is completely wrong, because whenever I create an instance of the astronaut, it will crash at runtime. And I don't want that. Instead, I would love to have these two parts change and use this other pattern that is an implementation of a template. I'm outside of time, is it? Okay, so in this case, I will be using a protocol that has the 4 methods that have to be implemented in order to fulfill with the protocol, but only 3 of them will be implemented in the extension. So whenever you create an astronaut method, you either create a method here that is the one that is missing, or it won't compile because it does not implement the full protocol. You will get an error at compile time. That is what you better get instead of the other one. Much better implementation of the template method. Okay, so finally, and this is the closing one, what can we do next? So my recommendation is to pay attention to the architecture. It is something that you better do sooner than later, because the sooner you will do it, the more return that you will get from that investment. But in any case, it is never late to start caring about the architecture in your application. I would recommend to use principles in order to get the most benefit of your architecture. When you have to take the decisions, instead of this person of this other has told me to implement this architecture like this, I would recommend you to use principles that will provide you with a better reasoning for taking one decision or the other. I also think that it has huge advantage to use design patterns in your architecture, because these are solutions that have been proven, and smarter people than me already know that they work and they can be applied to my code as long as I commit to certain requirements. And finally, this can never be a reason for not shipping. So if you are late to make the commit and have your product ready on time by tomorrow, do whatever, ship it, ask for a loan in terms of architectural debt or technical debt, and you will pay later on. So that's a coupon for a training in Amsterdam. If anybody wants to go to this training in Amsterdam, just let me know or grab me somewhere here today or tomorrow. That's something that I do there pretty soon. And since we are going to the after party, I would say na zdrowie. So. Yeah.